Good morning, everyone. Today, assignment 54, we're going to be looking at practicing all those different derivatives that we've been talking about recently. We're going to focus certainly on um, the exponential and log ones, but really the inverse trig ones, and well, it's just going to be extravaganza of practice. But first I want to do a little Pell work problem. And it starts off with a table. And we've got 2 and 8 and f and f prime, 3, -1, -2, 4. And, I'd like to know what g prime of 2 is. And I'll tell you that it is known that g is defined as f to the third x, which you know is the same as f of x to the third. Okay, so find g prime of 2, please. That says f to the third of x. And you can see it here. Yeah, sorry about that light. There's not enough light outside yet. It'll get better soon. Okay, done? Did you come back? Have you done it yet? Go, hurry up. I want to do this problem with you. Okay, so g prime is 3 times, leave the inside alone. Don't forget to subtract 1. So many people forget to subtract 1 here. Times the derivative of the inside. Derivative of f is f prime. If I'm looking for g prime of 2, that's going to be 3 times f of 2 squared times f prime of 2. F of 2 is 3. 3 squared is 9. 9 times 3 is 27. Times f prime of 2 is -1. And so I get -27 here. Yeah? Okay. So, how about this one? Find h prime of 2. And it is known that h, just love that statement, it is known. Known by whom? Known by the local gazelles. The gazelles know. Okay, h is defined as f of x to the third. Similar, but completely different from the last problem. F of x to the third. I'll put it over here so it's not in the glare zone. All right, so, okay, here we are. H prime then is going to be f prime, leave the inside alone, times the derivative of the inside, 3x to the second. And we want h prime of 2, so that's going to be f prime of 2 to the third times 3 times 2 squared. So that's f prime of 8 times 4 times 3 is 12. F prime of 8 is 4, so I get 4 times 12, or 48. Okey-doke. And the last one that I'd like to do like this. These problems are so common on the AP exam. The last one is I'm looking for p prime of 2, and it is known that p of x is f squared x times x to the third. So please notice that this is a product of two functions. I have to use the product rule. Okay. Off you go. Come back when you're done. Did you get that p prime was going to be 2f times f prime times x to the third plus 3x squared times f squared? Because remember, when you see this f squared, that's the same as f of x being squared. So the derivative here, take the derivative of the outside, leave the inside alone, come back and take the derivative of that inside. And remember, we're doing product rules, so derivative of this times that is all this. Get to the plus sign, and then I'm doing the derivative of this times that. Okay, now let's, having gotten through the challenging derivative part, let's see if we can get through the pre-algebra part and plug a 2 into our derivative. So I want 2 times f of 2 times f prime of 2 times 2 to the third plus 3 times 2 squared times f squared and f of 2 squared. I think actually writing this out like this really reduces people's mistakes. I know that we could probably easily do this in our head, but it's also a place that's really ripe for mistake picking. Okay, so f of 2 is 3, so I'm going to have 2 times 3. F prime of 2 is negative 1. 2 to the third is 8, plus that's 4 times 3 is 12. F of 2 is 3. 3 squared is 9. So what do we have going on here? We've got 6 times 8, it's negative 48. And over here we have plus 1 over 8. And it looks like then I'm going to have 60. All right? Excellent. So let's see. Yeah, that's probably bearable now. So yeah, I kind of want to go over a whole bunch of derivatives. But first, I want to talk about this problem. It would be number 49 in the homework. And the directions say you've got the curve y equals e to the x, and you're looking to find the equation of the tangent line to y equals e to the x that passes through the origin. Now, we did one of these not long ago. It was find all the tangent lines to 9 minus x squared that pass through the point 1, 12. And there turned out to be 2. And the technique we used in that problem to find these two tangent line equations is pretty much the same technique I need to use now. So this is an excellent pop quiz on, do you remember how we did that problem? All right, so what information do I need in order to write the equation of a tangent line? I need to know a point, and I need to know a slope. Well, I don't have any points. I can draw this, and this is yet another example of when having a good graphical sense can be helpful. So here's my tangent line that passes through the origin. But I have no clue where this point is, except that the x's and y's are both positive. So I'm going to call this x, comma, I could call it x, comma, y, but I'm just going to go with x, comma, e to the x. Now, what did we say would be true? And of course, we know that the origin is 0, 0. What did we say would be true about the slopes at this point on the tangent line and on the curve? That's right, we said the slopes would be the same. So what I know is the slope of the tangent line could be written as e to the x minus 0 over x minus 0, right? I'm using this ordered pair and this ordered pair to do the slope formula. So I have e to the x over x. That's the slope of the tangent line. We said the slope of the tangent line and the slope of the curve need to be the same at that point of tangency. And another word for slope of the curve at a point is the derivative. So I'm looking for the derivative of y equals e to the x. And so we know that y prime is e to the x. So what's going to be true about the slope of the curve and the slope of the tangent line? Yes, they're going to be equal to each other. So let's set them equal to each other. E to the x over x equals e to the x. Where did you go? Okay, sorry, just a little scared there because the last time I tried to make this video, the screen went dark. Okay, so we've gotten over here. We've set the two slopes equal to each other. I'm going to multiply both sides by x. Okay, e to the x equals e to the x times x. And this is an opportunity to really screw things up sometimes. It wouldn't be so problematic in this situation, but I want to get all the stuff on one side and factor. Sometimes it's fine to divide by e to the x, or in that situation, whatever you've got. And often it is not fine. So I don't like modeling occasionally bad behavior. Instead, I'm just going to write this. And then I'm going to factor out e to the x. And so now I'm going to solve this by setting each factor equal to 0. Well, e to the x is never equal to 0. This is an exponential function. There's a horizontal asymptote at 0. So I don't get anything from that. But I do get over here x equals 1. So I think this point is x equals 1. And then e to the 1, or e for that point. So now I've got the ordered pair for the point. I still need the slope. So we could either put our 1 in here or in here. Y prime of 1 equals e to the 1. So what's the tangent line equation going to be? Yep, no problem. It's y minus e equals slope e x minus 1. Tangent line equation. Okay? So you've seen this sort of problem twice now. Yeah. You need to expect to be able to do that. And I don't believe many of you are quite yet ready for that. So I'm telling you this so that you actually, practice it a little bit. Okay, so here we go. Y equals theta e to the cosine theta. If we were in class, we'd be doing these on high-speed whiteboard problems. So go to it. Oh, what is it that I want? Yeah, I want to know the derivative in each case for all the rest of the problems. Okay? Okay, welcome back. Y prime is 1 times e to the cosine theta plus theta times derivative of e to the cosine theta is e to the cosine theta times the derivative of cosine, which is minus sine. Excellent. Yes, you could in fact go by e to the cosine theta and be left with 1 minus theta sine theta. So multiple choice answer for your response answer. All right, next one. What about y equals e to the secant 3 theta? Find y prime, please. Hey, welcome back. So y prime is going to be itself e to the secant 3 theta times the derivative up here. The derivative of secant, remember, is secant tangent, but we've got that. So it's going to be secant 3 theta tangent 3 theta times the derivative of that innermost function, 3. Excellent. Let's go. There's more learning. Y equals 2 to the sine x. No, I'm not using logarithmic differentiation here. I'm doing the derivative of an exponential. So y prime equals itself times ln of the base times the derivative of the inside function. Okay. Yeah, exponential. That's a number. That's not a function. Okay. I guess you could make the argument that y equals 2 is a function, but that's a number. Whenever I have a number to a power, I'm doing it as an exponential. So how about y equals tangent of e to the minus x? It's not tangent times e to the minus x. It's tangent of e to the minus x. Hey, welcome back. Did you get secant squared, leave the inside alone, times the derivative of the inside, which is itself, times the derivative of that innermost, negative x. So what would happen if we change this problem slightly and have y equals tangent x times e to the minus x? What would our derivative be then? I mean, this is a different function. This is product and this is composition. Okay, because I've got a product, my y prime is going to use the product rule, which is secant squared times e to the minus x, derivative of this times that, plus that times the derivative of this. Derivative of e to the minus x is e to the minus x times the derivative of the inside, negative 1. Okay. How about y equals sine of e to the 4x? 5, 4, 3, 2. Well, you'll never get faster if you don't push yourself to be faster with this. 6 times 7. Oh, come on. So y prime, derivative of the outside function, leave the inside alone, times the derivative of the inside, which is going to be e to the 4x, times the derivative of the innermost, 4. How about y equals x e to the x? What would my derivative be here? Did you get that y prime would be 1 times e to the x plus x times e to the x? So derivative of this times that plus derivative of this times that. And of course you could factor out e to the x if you felt so motivated. I would not if this were a free response question, but I definitely would if it was a multiple choice question. Alright, so how about this one? Y equals x times 2 to the x. So, did you get y prime equals 1 times 2 to the x plus x times the derivative of this is 2 to the x ln 2. A lot of people forget that ln 2 when taking the derivative of 2 to the x. Hey, what about this one? X times log base 2 of x. What would y prime be here? Okay, so derivative of this times that plus that times the derivative of this. Remember, the derivative of this is 1 over x ln 2. And if you don't remember that, you might want to go back. We went over these in the second part, part 2 video from assignment 53. How about y equals square root of x times 3 to the x? Well, y prime, I see product, it's going to be product. So, what did I get? Well, 1 half x to the minus 1 half times 3 to the x, that's the derivative of this times that, plus that, x to the 1 half times the derivative of this, which is going to be itself, times, what was that again? Yes, exactly, ln of 3. Remember, we're going to be setting this equal to 0 very, very shortly, so I'm going to practice factoring out the smallest power of this common factor. I also see a 3dx that I can factor out. And so what's left over? Well, I took out this, I still have the 1/2, and then my plus sign. I took out this, I factored a negative 1/2 out. So that's going to leave me x times ln3. All right, there's y prime in its tidy form. And so I would be setting these factors equal to 0. Different critical points, but more on that later. So, how about this one? Y equals sine x raised to the cosine of square root of x. What do you get here? What does it look like? Okay, so we know this is logarithmic differentiation because I have a function raised to a function. So let's take the ln of both sides. This is a big old product rule over here. Don't forget to take the derivative here. The derivative of ln of stuff is 1 over stuff times the derivative of that inside function, the derivative of the inside with respect to x. And then here I've got a product rule. So this times the derivative of that, cosine square root of x, times the derivative of ln is 1 over stuff, times the derivative of stuff, plus ln of sine x times the derivative of this. I'm going to go join the wraparound universe and come back over here. Derivative of cosine is minus sine, leave the inside alone. Still need to come back and take the derivative of that square root of x, which is 1/2 x to the minus 1/2. Wow. Still have to multiply both sides by y, and then turn that y back into this x stuff. I think to give myself a little more space, I'm going to call this cotangent. So I'm going to have dy dx equals y times cosine square root of x times cotangent x plus, no, because that negative times that positive is going to give me minus ln sine x times sine square root of x times 1 over 2 square root of x. Whoop! Remember, we still have to change this out for that stuff. So it's going to be sine x raised to the cosine square root of x. Okay, woof. I think you should do one. Y equals x raised to the tangent of ln of x. Okay. Please find y prime. Okay. Did you remember to take the ln of both sides and then bring this power down? Tangent of ln of x times ln of x, because I took ln of both sides. Little ln, bring that down in front. Okay. This is a product, but this is composition. I take the derivative here, I get 1 over stuff times the derivative of stuff with respect to x. And here I have a product rule. Tangent of ln of x times the derivative of this plus this times the derivative of this. Derivative of tangent is secant squared, leave the inside alone, times the derivative of that inside, 1 over x. Anything I can factor out? Just the 1 over x. I'm going to multiply both sides by y, and I'm going to factor this out. You don't have to factor this out in Chapter 4. In Chapter 5, you'll be setting all the factors equal to 0, so you probably have to do that, but I can't imagine doing that in a problem quite like this. So, but I'm going to factor out the 1 over x to save a little space. So I'm going to have dy dx equals y times 1 over x, so I'll have y over x And then I've got tangent of ln of x plus ln of x times secant squared ln of x. Remember, though, no y's here at the end, please. So I'm going to write that as x raised to the tangent of ln of x. And remember, we're dividing, and the bases are the same. So what do we do when we're dividing and the bases are the same? We subtract the exponents. So actually, we could get rid of this and do that. Would they really do that to us, Mr. Cooper, on the AP exam? You know, they really like showing off their algebra in multiple choice questions is all I'm going to say. All right, so let's do some quick review of 3x squared, of some logs. And derivative. So, did you get 1 over stuff times ln of the base? What's the base here? Well, it's just log. We know it's log base 10. So I'm doing ln of 10 here, times the derivative of the inside function. Okay. How about y equals log base 4 of sine x? What would y prime be here? Did you get 1 over sine x times ln of 4 times the derivative of sine, which is cosine? And so I guess we could call this 1 over ln of 4 times cotangent x. And again, no, I don't have to simplify to this. If it's a multiple choice problem, though, I might see this and not this. And if it's a free response problem, it's probably the case that I'm going to be setting the derivative equal to 0. And you could do that either by setting the numerator and denominator equal to 0, because this finds when the derivative is 0, and this finds when the derivative is undefined. Or we could do it that way as well. All right. How about y equals sine of x? What's that one going to be? Good. Y prime is 1 over square root 1 minus x squared. Yeah, I know. You haven't remembered them. That's why we're going over them now. How about y equals tangent inverse of x? What would y prime be here? Put your head in that place, right? This is not raised to the negative 1 power. This is inverse sine. So no chain rule here. Okay. So what about this one? Inverse tan? 1 over x squared plus 1. And do we remember the derivative of secant inverse? There's only a couple of videos ago. We know that y prime is going to be 1 over absolute x square root x squared minus 1. So we should be able to comfortably take these derivatives. So how about this one? Y equals cosine inverse of 2x minus 1. Okay? Y prime equals the derivative of inverse cosine, remember? The co-derivatives always have that negative 1. So I got square root of 2x minus 1 squared minus 1 times the derivative of the inside function, which is to FOIL this out and not FOIL this out. Well, again, I feel like there could be some canceling there. So I'm going to have negative 2 over square root of 4x squared minus 4x plus 1 minus 1. And see, these are going to cancel. And look, I could factor out a 4 and an x here. But why, Mr. Cooper? Why? Well, let's see what happens. X minus 1. So I can't take either of these out. I can't take the x because I don't have 2 of those x's. I don't have 2 of these x minus 1s. But 4 is 2 times 2. So I could, and then I could, and so my answer is going to be negative 1 over square root of x times x minus 1. That's more likely to be the multiple choice answer than that one is. Just saying. Okay, let's do a couple more of those. How about y equals cosecant inverse of 1 over x? Give that one a try. Come back when you're done. Did you get that y prime would be 1 over absolute 1 over x times the square root of 1 over x squared minus 1? Not done yet. That's just the derivative of inverse cosecant if I put the minus there. I still have to come back and take the derivative of the inside. And 1 over x is the same as x to the negative 1. And so the derivative will be negative 1 x to the minus 2. All right. Yes, I do think this is worth taking the time to tidy up, just because I think you need practice seeing it and thinking about it. You got a negative 1 times a negative 1, which is a positive 1. You got x to the minus 2, so that's going to flip to the bottom and become x to the positive 2. So I've got 1 over x squared times absolute 1 over x. Now here, I'm going to have 1 over x squared, but minus 1, so I'm going to make a common denominator by multiplying by x squared over x squared. So now I've got the square root of 1 minus x squared over the common denominator. Excellent. But what I'm going to do now is I'm going to split this double-decker radical into two separate radicals. And why will I do that? Well, I can pull out an x here. In fact, it's an absolute x that I'm pulling out. So then, that's the stuff under the radical, all over absolute x. And, just to keep size in mind, this goes with this, and this is on the same level as that. So let's draw that a little easier for us to see. So I'm going to get x times x, which is x squared, and I have that x squared there, so they cancel, and I'm left with 1 over square root of 1 minus x squared. Hey, isn't that the derivative of inverse sine? Sure is. So guess what? This is equal to sine inverse x. Okay? Yeah, I'm slyly throwing in little identities for you. No, you probably don't need to remember that inverse cosecant of 1 over x is equal to sine inverse of x. But it is, curious to see. All right, last one of these, and then we'll go to a different round of problems. Cool. Please take the derivative of this. Okay, welcome back. Cotangent inverse derivative, negative 1 over stuff squared plus 1 times the derivative of stuff. And no, I don't really see any simplifying I can do here. I could write this as. And by the way, that x has to be multiplied to all of this. So, ln squared x plus 1 might be my final answer. Yeah, we could distribute, but no, I usually avoid that because when I'm doing stuff beyond taking the derivative, I'm usually wanting factored form so I can set the factors equal to 0. Okay, so now let's take a look at some chapter review. So how about y equals pi to the x minus e to the pi plus x to the pi? That's a great problem, isn't it? Well, think about what you're looking at. It's very important. And come back when you're done giving it a try. Hey there. So this is a number. It's like seeing 2 to the x. This is an exponential, right? We've got a number raised to an x. So y prime is going to be the derivative of this will be itself times ln of pi. Now, what about the derivative of e to the pi? Well, e is a number, pi is a number, a number raised to a number is going to be a number. This is just a constant. It's just some number. So what's the derivative of a number? 0. Plus, and over here, this is x raised to a power. I'm not going to use logarithmic differentiation. I'm using the power rule. The power rule says bring down the pi, Don't forget to subtract 1. And, this is not doing chain rule here, folks, right? I'm not taking the derivative of that, because if I take the derivative of pi, I get 0, and that cancels all that out, and you don't want to go to that place, right? So you really have to know this is an exponential, this is a power function, and neither of them is logarithmic differentiation. Okay. Woof. How about this one? Y equals e to the 2x over x squared plus 1. Yeah, I'm going to do it with quotient rule, because quotient rule shows up on the AP exam in a way where you really don't want to flip the bottom up and raise it to the -1 power. So let's just practice quotient rule a little. Y prime would be low d high. The derivative of this is going to be itself times the derivative of that inside function. Yes, I agree, we could write ln of e because that's the derivative of the exponential, but we know that the ln of e is 1, so I'm not going to bother with that. So we've done low d high minus high d low. The derivative of the bottom is just 2x all over. It's funny how many people get through that and then completely forget about the bottom, and I'm one of those people. I do see that I could factor out an e to the 2x, but I'm not going to have anything, I'm kind of wondering if I'll have this sort of polynomial, and will that polynomial be factorable? I don't know, let's see. E to the 2x comes out, and what am I left with? 2 times this stuff minus this over x squared plus 1 squared. Well, if I take out a 2 from all of these, I'm not going to be able to factor x squared minus x plus 1. Yeah, that doesn't factor for me. So, I might just leave it here for free response, and pretty much here, but I'd probably flip those two for multiple choice. Okay, how about y equals cosine of sine inverse of 3x? Sure, y prime then is the derivative of cosine. Leave the inside alone, times the derivative of the inside inverse sine, 1 over square root 1 minus stuff squared, right? That's got to be a 9, not a 3, because you're squaring this and squaring this, times the derivative of the innermost function, so times 3. I'm sorely tempted to cancel those out, but I'm also scared and timid, because, well, I shouldn't be, because that's not an angle, that's an upness, and so I should be able to cancel those. So I believe that these will cancel. I'll have negative 3x times 3, or negative 9x over square root 1 minus 9x squared. I like to think that the AP is not that mean. Okay. I'm going through these quickly because we should be comfortable with this stuff. You might want to watch the video a second time. You might want to send me GroupMe questions about any of these as I go through them. I'm happy to answer your questions. Okay, so look, a number raised to a power. So this is y equals an exponential's derivative is itself times ln of the base times the derivative of the inside function. Yeah, I really want you to get that comfortable with this stuff. How about y equals 2 to the negative x? That gentle, kind line. 5, 4, 3, 2, 1. So y prime should be itself times ln of the base times the derivative of the inside. And there we go. So what about extending that to this situation? Y equals 2 to the negative 4x times sine of pi x. Okay, hi there. Did you notice it was product rule? So y prime will be this times the derivative of this. Don't forget to take the derivative of the inside pi x function, plus this times the derivative of this exponential is going to be that exponential. Don't forget ln of the base. That's the most commonly forgotten bit. And don't forget to come back and do the derivative of the inside. Okay. I could take these out, but really that's all I could take out. So I don't think I'm going to put any more time into simplifying this. Next, how about y equals x squared plus 1 over square root of x? All right, are you thinking about quotient rule here? Yeah, I think quotient rule is good to practice, but you know, we also did this both last year and this year, where we split this fraction in two, and then this is x to the 1/2, this is x to the 2, I'm dividing and the bases are the same, so this is going to be x to the 3/2 plus, x to the negative 1/2. This is a pretty easy derivative, so I'm going to have for y prime, 3/2 x subtract 1, and then the derivative here is going to be minus 1/2 x to the minus 3/2. So that's an answer to this problem. I probably want to factor out the 1/2 and the x to the minus 3/2. But I know that many of you are thinking, hey, let's do quotient rule here. So let's go back and do this with quotient rule. Now look, this is about to be a linkage error. And a linkage error is where you say two things that are equal, but really they're not equal to each other. So I was about to take the derivative of this and put it on the other side of the equal sign. The derivative of this is not equal to this. At least I don't expect it to be. So, no. Y prime equals low d high minus high d low. The derivative of x to the 1/2, because that's what square root of x is 1/2 x to the minus 1/2. And don't forget, over low squared. Square root of x squared, yes, you can use absolute value of x. I'm just going to use x. Okay? I think these square roots of x's cancel out. So I might be, yeah, because that's 1 over square root of x. Oh, no. This is one of those factoring problems. Though it does look like maybe I'd be able to factor that trinomial. Yeah, not sure. And would rather get through some more of these than practice simplifying that. But if you want to practice simplifying it, then by all means, send me a message and we'll practice simplifying it together. How about this one? Please find the derivative of this. Okay. Y prime, derivative of ln of stuff is 1 over stuff times the derivative of stuff. The derivative of sine is cosine, derivative of cosine is minus sine. And so I end up with cosine minus sine over sine plus cosine. Good? All right. How about this one? Y equals tangent inverse of u over u plus 1. Yeah, no. Y prime is 1 over stuff squared. Here's stuff, u plus 1. Now you can't split this into two. Splitting this up only works when you've got more than one thing on the top and only one thing on the bottom. You get two things on the bottom and only one thing on the top, so I can't break that up. I have to leave it like this, and if I were to take this further, it would be u squared, u plus 1 squared, and that's a FOIL event. But hopefully it won't come to that. Okay, so plus 1 times the derivative of the inside. Well, the derivative of the inside requires me to use quotient rule, low d high, so u plus 1 times 1 minus high d low. The derivative of this is 1. all over u plus 1 squared. Now it looks here like this positive u and this negative u, they're going to cancel, so I'm just going to have 1 over u plus 1 squared times over here, I've got 1 over u squared, u plus 1 squared plus 1. I can't cancel this with that unless I make a common denominator here first, which is going to be u plus 1 squared over u plus 1 squared, and I just, I'm sorry, I'm not feeling it. If you want, you can go further with that one, but I'm not going to. Instead, I'm going to look at y equals ln of sine of x over 4. And please note this is sine, not inverse sine. Take the derivative, come back when you're done. Okay, did you get that y prime is 1 over stuff times the derivative of stuff? The derivative of sine is cosine. Leave that inside alone. Times the derivative of the innermost function. Please don't think quotient line. Please think that this is 1/4 x. Your middle school teacher tried very hard to convince you that this and this were the same thing, and the reason they wanted you to see it was so that now you don't try and use quotient rule here. You say, oh look, I have a constant times an x, and the derivative of a constant times x is just that constant. Okay? No, really, your middle school teacher really did try and show you that then, so that when you were here now, this would be happy, as opposed to you're trying to use the quotient rule there. All right, let's just do 2 more. All right, maybe 3. Y equals e to the minus pi plus pi to the minus e plus pi to the minus x. Okay, we talked about one of these earlier today. What can you do with it? Y prime. Okay, I don't see any variables here. So this is a number. The derivative of a number is 0 plus pi to the negative e. I don't see any variables here. So this is not pi to the x. This is a number raised to a number. This is a number. The derivative of a number is 0. But over here, I do see a number raised to a variable. So this is an exponential. The derivative of an exponential is itself times ln of the base times the derivative of the inside function. So my answer here, y prime equals negative pi to the negative x ln of pi. Some people like moving all the numbers out in front. It doesn't matter to me. What you do with that? Okay. How about this one? Y equals ln e to the 4x plus ln of 4. Yeah, so what are you thinking about here? Are you thinking about using the power rule for logs to bring down the 4x? I know that's not a derivative. So if I don't think about using my algebra here, I should end up with 1 over stuff times the derivative of stuff, which is itself, times the derivative of that innermost function. And then these would cancel, and I'd be left with 4. The derivative of ln of 4, yeah, no variables there, so that's just going to be 0. So y prime is this. But really what I was thinking about doing for this problem, ln e to the 4x plus ln of 4, I was thinking about using the power rule. So not y prime yet, still y. 4x ln of e plus ln of 4. And now when I go to take the derivative, well, that's 1 times 4x. So the derivative of 4x is 4. And the derivative of this number, ln of 4 is a number, there's no variables over here, is just going to be 0. So I end up with 0. Great. And then the last one I want to look at with you is y equals e to the tangent times sine x. Or was that sine x supposed to be up there? I don't know, we'll do that one too. So y prime going to be what? Oh, yeah, it is a product. So I have to use product rule. I've got this times the derivative of that plus that times the derivative of e to the stuff is got e to the stuff as its derivative. Don't forget to come back and take the derivative of tangent, which is secant squared x. All right, yes, I could factor that out, but there's not going to be any tidying up I can do, so I don't know whether it would be worth it. Okay, so yeah, what about this other problem? E to the tan x sine x. And we'll call that one the last one, absolute last one. Okay. All right, so what do you got? Y prime, it's e to the, so we know its derivative is e to the, times the derivative of this stuff. Well, that's product, so I need to use product rule. Secant squared sine x plus cosine x times tangent x. And there, yeah, I could take a sine out of each of those, and then the cosine over cosine would become 1. But taking that sine out, I don't really feel like it gets me anything. So I guess I could see sine x, secant squared x plus 1. And then here I still have e to the tangent x sine x. Secant squared minus 1 is tangent squared, but secant squared plus 1 is not anything I know, so I think I'm going to be done. And I hope this was a helpful video for you. But really, you need to be practicing these derivatives. All right. Well, thank you for joining me today, and I hope you have a wonderful rest of your day. Take care, everyone.